Ankush, let us know whenever you're recording. Okay, awesome. Yes, thank you. Hello, everyone. Welcome to the 12th OTC talk. Um, we have Sahil today. We'll be talking about securing open source software. And Sahil has been an engineer at SafeDep for over a year, and he has built quite a few nice projects. Uh, some being an entire database called AtomXDB, Runbox, Sandbox in C that he built from scratch, and a few other things like storage engines in C and things like that. So yeah, we recently saw Sahil's talk at NullCon regarding this topic about open source software security and preventing like supply chain attacks and things like that. So we were like, okay, we want to know what the talk was about, and we also want to learn about it. So we invited Sahil to educate us and to tell us about what he's been learning and what he's been doing. So Sahil, over to you. Just tell us more about yourself and take it over.
Thank you, Harsh, for the introduction. So, hey everyone, I'm Sahil, and today I'm going to present a talk related to supply chain security. So, is my screen visible?
Yes.
Yes,
Okay. So, the topic is when your package manager became a weapon. So, it's basically like for developers or vibe coders, you may say, like who aren't really aware about the threats a single package manager might carry. So, I'm Sahil, as Harsh already introduced, and I'm working at software at SafeDep, which is a startup securing open source code. So let's start. And so everyone knows zombies, right? Zombies have this special effect of uh, just starting, like creating that whole, spreading those infection around and just creating that worm effect. So zombies are zombies do exist in real life, but in the software world. So let's take this out. So let's take this package as an example, which looks normal, looks very ordinary, and how every npm package looks like, but let's check what's really special about it. So suddenly the package had a large size change. So as you can see in 7.2.0, the package size was only 12 KB, but in a new version, it jumped to 2 MB. So what do you think was in those 2 MB? So first of all, there was a new post install script added, which was executing some bundle.js. So let's look at the attack and what did that bundle.js actually contain. So it had various phases executing the post script. So as soon as the developer executed npm install control debug, basically installing the package, the post install script gets executed and all your tokens are stolen, be it your AWS, GitHub, npm, and were sent to the attacker's webhook. You wouldn't even know before your tokens was stolen and sent to the webhook of the attackers. So the next phase it started was the GitHub lateral movement, where it used your stolen GitHub token and injected all your workflows. So it made all your private repos public with the tag Shai-Hulud migration, and your private repos were exposed. So the next phase, the worm effect, where the zombies effect is relatable. So all your npm packages were now were able to access by the npm token the attacker got access to. So it added the same effect to your npm packages. So each of your npm package was affected now. So it created this worm effect where each and every package was getting affected and infected as user install this package. Well, you might think the attack stopped here. Just after 2 months, Shiloh 2.0 came and it was even stronger. So some differentiates you can see is its runtime from node to bun. It changed its hook where it shifted to pre-install, and the obfuscation got even heavier. The size change got to 9.7 MB from 2 MB. It started to get more smart. It got CI/CD aware. It started to destruct the files itself. It started to mess up with the file system and also destroyed them. So there was no chance of recovery too. It started to affect the self-hosted runners itself. So previously, as I told, like the workflow were injected, but now the machines running those workflows were also affected. So it was even much more smarter. The repos that were affected were even higher than 1.0, and it even got Windows platform aware. So we already talked about the impact. So there were a lot of GitHub repositories impacted, a lot of npm packages, and all those credential threads. So here is an example of those GitHub repos that were affected. You can see the Shai-Hulud second coming and 26 plus K repos affected. So let's look at the traditional tools. Like, why didn't any traditional tool actually scan for this attack? So many of the traditional tools actually are not really aware of those zero-day attacks. So many of those tools, such as npm audits or depend about are dependent on known attacks, such as known CVs or known malicious packages that are disclosed by some user or some developer. But zero-day attacks are still very threatful and don't really get much attention. And another way could be code reviewing the package you are installing. But you can't really just review all those packages you are looking at. There are thousands of or hundreds of dependencies each package might have, and those package might have its own transitive dependencies. So let's have a look at how at SafeDev we detected this campaign of Shai-Hulud and how did we flag those packages as malicious. So SafeDev has an architecture where it continuously monitors all those public registries such as npm, rubygems, and all other public registries. So as soon as a new package or a new package version is published, it our analysis system gets triggered and it goes through different stages such as static code analysis, dynamic analysis, and after all the analysis is completed, it is stored in a database. So let's have a look at each analysis more deeply. So static analysis consists of various different analyzers. So capability detection is one of them, which basically tells what all does this code actually what does this code actually do. So such as a package might be importing some network libraries, some crypto related library, some file system related library. So we can actually know, does this code actually have access to some network operations, some file system operation, and stuff like that. So YARA rules. So YARA rules are another great for pattern matchmaking. So there are various, like known malicious patterns which can be triggered for these, such as a new script is new a malicious script is being added to a package and it follows some known malicious behavior. So we can actually match the same pattern if it follows some highly used malicious behavior. And call graphs. So call graphs are also like very similar to knowing and understanding the code flow. So it helps us get the order of the execution. The code follows like what is being called and when is it being called. And based on all these analyzers, we get to know if the file is actually suspicious or not. So there could be some risk capabilities, right? Uh, uh, a package or a file might be trying to, like making some network operations, trying to read some file system. So we can mark those files as potentially suspicious, right? Or a new YARA rule might be triggered. So if a file is risky, we send that file for LLM analysis. So the LLM gets the whole source code of that file. It does a semantic analysis and checks if the file is really malicious or not, like based on its understanding, based on the code it's being executed. And we have multiple other analyzers such as getting the metadata of the package. Does it exist in the OSV database, or does it have any pre-install or post-install scripts? Checking for embedded executables and stuff like that. So it does not stop there. So static analysis gets us only to somewhere we can get to know what it does, but we cannot really know its runtime or how it is actually being performing stuff. So there were some known limitations, such as the halting problem. So a program cannot really determine if if this program or the package will stop or run forever. So we cannot really statically know if this program is going to infinitely run or is it going to stop at some moment. So this is a very big limitation. And Rice theorem is also like kind of based on it, where we cannot really uh, surely know what would be the output based on all those different inputs a package is given. So they could be like different algorithms or different way of package being executed based on different inputs it might have. So we can only guess what it might be actually doing. And also there was a high case of high false positive rates. So whenever static code analysis is done, we always take the worst case scenario where if even if a risky or uh, a slight risky, like uh, a rule is triggered or a capability is found, it marks it as suspicious. So we can't really go for the mark it as or ignore it because it might actually be malicious. So we always go for marking the package as suspicious. So we do not really have much context of the package. Like a package might be a network library. So its default behavior is accessing network, making network calls, but the capability or the YARA rules might mark it as suspicious because it makes network calls. And also not being able to determine the runtime behavior. So the package might be making some network call, getting the response, and might be executing it. But at static analysis, we can't really know what is it really getting and what is it really executing. It might be getting some payload and executing it. Now we don't really know what is the payload. So there is this some limitations that static analysis had. So we uh, started to get aware of it, and we started to think of how can we overcome those limitations and start to build dynamic analyzer. So before we started, like we had some goals in our mind, which was running the open source package in sandbox environment for obvious security reasons, observing the runtime behavior and getting to know what does the package actually do. And the most important was correlating the static analysis result with our dynamic result and classifying the package as malicious or safe. But is it really that simple to execute the package? Let's look at the challenges we faced while building the dynamic analyzer. So first and foremost, the biggest challenge was how can we execute a library? So there are thousands of packages, or if not millions. We can't really execute each package. Some package might be a library, some package might be a CLI. So we can't really using a single program execute each of those. So the biggest challenge was how do we actually get to know the runtime behavior of package? Each ecosystem had a different behavior. Ecosystem had different ways to execute the package, and also the scale versus accuracy trade-off. So a dynamic analysis takes up a lot of computing, a lot of resources, and adding more and more analyzers or adding more uh, adding more competition, or maybe even if you're like for example, if you add some new analyzer or new ways to determine the runtime behavior, it might give you a better output for a single package, but it might also bring down the scale by a lot. So you have to maintain that scale between the accuracy and scale, because there might be a new campaign of malicious packages which might be missed because we were actually analyzing some previous versions of the package. And the biggest challenge was why not just go ahead with the Google package analysis? It's also very similar. So the biggest challenge we faced with Google package analysis was not being able to correlate our static analysis results, which was one of our biggest goals when building dynamic analysis. So Google package analysis was fully internal to Google, like fully coupled with Google's internal system. So it was not possible to correlate with static results. So this is how the overall flow looked like for dynamic analysis, where we had an executor which basically took some package as it got, and it spun up a new sandbox for each package where we did so as shade, we can't really execute up each package. But for starting, for initial purposes, we started with installing the package because a lot happens at the installation stage itself. As we check the package, it was also doing all those malicious behavior at the installation stage itself. So we started with checking the runtime behavior at the installation stage itself. So in the sandbox, we do installation of the package where with the help of Falco, we gather all those system calls, all those behavior that the package is executing and collect them in an events DB. So this is how it looks like a bit more deep. So we have a NATS where any new package is published and a new package version is published. It gets to the executor and the executor is responsible for spinning up a new sandbox. And this is how the runtime monitoring looks like. Where Falco is fully dependent on EBS to gather all those system calls or gathering all the runtime behavior of a package, which is basically the installation of a package. So in the case of the control dlug package I shared, it started to if we install the npm install control dlug in the sandbox environment, we would be able to know like what all network calls it made, what all file system calls it made, because its malicious behavior was at the installation level itself. And with the help of Unix socket, we basically shifted all those Falco events to an event handler, which was responsible for sending those events to the events DB. So here is an example of the Falco detection rules. We have various many, but this is an example which basically tells and finds out if there is an attempt made by the package to search for private keys or getting the passwords, or if there was a new binary that was fetched in the container and was tried to execute it. Well, there was much more threats to the infrastructure itself. So some threats that we did consider was reverse shell access, where the attacker itself might try to gain, where the victim or the user that's trying to install the package might try to make contact to the attacker shell. So we try to make it as isolated and as empiric we can. The next was the container escape. So it could try to privilege and get more privileges. So we used the DINT approach where we had multi-layer sandbox, the Docker in Docker. And the next threat that it had was kernel exploit. So we had to make sure that package is not the package is not able to exploit any vulnerability in kernel. So we had like a we had to mitigate it using a dedicated node pool, because even if a package is able to exploit some kernel, all those internal services are not affected by this, and uh, only that node pool is affected, which is executing or scanning for these malicious packages, which is not that much serious or does not affect the internal services. And the internal network exploitation, where it does not try to it even if it tries to get some access to our internal services network, basically the pods or the node, we try to restrict it using egress, which is basically restricting the IP addresses and the uh, network access it has. And the last was the VM escape. So if a package really escapes a VM, it's like it has access to all of that internal service or of the like the no, Kubernetes itself. So it's a kind of a separate instance because you can't really mitigate a VM escape. It's like at a much higher level. So let's have a look at the what did we actually analyze during this Shai-Hulud and how does it look like in our internally. So here is an example. So as I showed you the Falco rule, so here is how it looks like. So here a rule was violated, or you can say triggered, which was basically dropping and executing a new binary in the container. So what it means is it tried to actually execute the truffle lock for harvesting all those credentials. As you can see, it executed Truffalog, harvested all those credentials. So another example is it, another rule violation by the package. So it tried to connect to an EC2 instance. So here's how it looks like, where it tried to make some connection to some port, which was AWS, some EC2 machine, and try to gain access to the AWS metadata, or you can say credentials. So why do you think how did dynamic analysis really change our analysis system? So we continuously scan for 30K or 35 plus thousand packages daily, and we have had this 167 million events till dates. And these events are uh, similar to these, which are like the rule violations or those rules that are affected. And this is an example of continuous monitoring that we provide in our platform. So here you can see that the packages are refreshed after each 5 seconds. So this is just a config. So all those packages are marked as clean or suspicious, which we think of. So how do we actually mitigate those risky packages and be safe from this? So there are two different tools that we currently manage and developer, and both of them are open source. So you can have a look at them, which is for developers and CI/CD. So let's have a look at the tool for developers. So PNG is a CLI tool, which is mainly just an wrapper over your existing package manager, such as npm, pip, pipe, burn, and many more. So before any package is actually installed on your system, PNG scans for that package, gets the analysis report of the package, and blocks if the package is malicious. So as you can see, this ESLint config TTL was an existing malicious package which which was blocked with the help of PMG. And WIT, this is another open source tool which is for scanning or using in CI/CD mainly. So WIT also supports policies where users can define their own policies, as package by not package might should have uh, minimum stars, should not be version should not be published, the version used should be published greater than 1 or 2 days, and many more policies. So this was how it looked like, where we scan for public registries, the safe dep architecture, and where these both tools sit in for blocking at install time and the CI/CD itself. So Shai-Hulud 3.0 may also come soon. Be sure to be safe and make sure that you are already ready for new surprises from the malicious threats. Thank you. Ship code, ship code, not malware. Yeah.
Awesome. Thank
If
you so
anyone
much,
has
Saj.
questions, yeah.
Yeah, fair enough. Thank you so much. Does anyone have any questions? I have a few, but in
Yeah.
case others have questions, please.
Okay, I joined in a bit late, but I wanted to know, this is just at the package once you install it, not at the runtime,
Mhm.
after the application is bundled. So can this be extended to the application runtime as well? So
So basically, getting the runtime of the package when it's really being executed, right?
yeah, so currently I guess Docker containers are essentially what isolates the different deployments which each other
But
thing. But the access, I would say we can have that layered as well.
yeah, but
This
you can't really, there are millions of packages. How can you really execute each package from a single program?
no, no, I'm not talking about executing packages. So the final bundle that we build, let's
Mhm.
say for from npm, we have this bundle as a like what once what we run actually we run. So having
Yeah.
that isolated. But again, yeah, we won't have access to environment variables or these kind of things, I guess.
Okay.
But
No, but Darshan. So, oh, sorry. Continue.
Yeah,
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 go ahead.
continue. had no.
So no, I was just saying to Darshan's point, I thought Sahil, y'all do dynamic analysis of the package, right? Before, and that is running in a sand. I know it's not running with all the packages that we have, but before you mark a package as safe, you are doing static code analysis, then dynamic as well, right? So you are running that, sandbox and then marking it as safe, right?
Yeah,
So Darshan, does that answer your question? Where it's like, yes, it's not being tested on your particular set of packages together, but at least the package itself has been run in a sandbox individually by
okay.
itself or whatever and tested, right, Sahil?
Yeah,
I
so
don't think so. The package, all the public APIs are run. Like,
mm,
do you test the public? So, static code analysis will test the public APIs before they are executed. That's fine. I was just thinking about this scenario, right? Where at this moment, so Karthik also pointed this on the chat. So this only verifies pre and post install hooks. So yeah, so they just like verify the hooks, not not the actual
yeah.
package like itself.
Okay, the actual package that when it's executed, we don't really know, right?
Yeah, exactly. So the code can be malicious itself, not just hooks.
Yeah, if the code is malicious, it would be flagged during the static analysis because
Yeah.
due to its like capabilities or the malicious behavior it carries.
No, you
But for the
cannot.
dynamic one,
The point of the Turing hypothesis is that you cannot flag all kind. You cannot determine the output without actually running it. And even then,
yeah,
even if
yeah,
you run it, there is no easy way to automate the uh, distinction between what is malicious, what is not malicious, based for
yeah.
each package.
I
So we
remember
have
there
a
was a
mm,
interesting malware in this like similar scenario, but how it skipped the firewall was it embedded all the information in the subdomain, and the DNS like DNS resolution would carry that information.
oh, okay.
Yeah, that was something I
Despite
don't think so. Would
tunneling over DNS,
yeah,
Computer File is a good video on that. But so
So
you are
Karthik,
just
to answer your question, like we do have a human in loop. Like so, after the analysis done at static and dynamic level, so we have a security researcher who actually verifies the results and marks the package as malicious or
but
safe.
they
Not
only
malicious.
check if the package has been flagged. So if, for example, I have a package that when it is imported or when a function is called, it triggers a payload. That will not be caught.
Yeah, but depends like what kind of payload it is. If it's obfuscated, it would be flagged at the first level of the static code analysis itself.
No, if it is fetching something and running in eval in JavaScript, for example.
Yeah, uh, let me just show you some example of the report.
That is a good point, Karthik, right? Right. It's contacting some random API and then whatever payload is getting, it's executing that, right?
Yeah,
You can't look for that, right?
yeah. So it's like a known limitation of the dynamic analysis. So let me just show
But
you.
I mean, it's questionable utility at this point because then I mean, yes,
Yeah,
postal service they are the highest value because they result in immediate execution. Although with PNPM and I think Yarn also have taken steps to limit the uh, code that can be executed during a package install. You have to explicitly approve the.
approve builds.
yeah. You can also like block these scripts for pre and the potential scripts.
But for example, if I have something like eval, fetch,
Yep.
you know,
So those come under like capabilities, or you can say yeah. So this is how an example static code analysis result look like. So where it kind of triggered some rules, and the LLM also found the potential script, and this was the same package control dealer, where it found some uh, a risky error rule match, you can say, where it had uh, math, unsigned bitwise math, and
all these are
found
just markers. No? These are metrics. So this is not actually
yeah
marker like.
proof for malicious behavior. Yeah.
So if you look at
Yeah.
the chat, if you have a package that does something like this, will any of your rules trigger?
Sorry, can you come again?
If you send a code snippet, if you have, say, one of your packages that does this, uh,
Mhm.
will it trigger any rules for you?
What does it do? Like,
I've sent
Check the chat. Check the chat.
oh, okay. It would trigger the YARA rule for eval match.
just eval.
Yeah, the eval match and network call.
Mhm. And eval match and network call.
Yeah.
How will it? I mean, why do you have a tool for just blanket network call?
Sorry.
No, if I have this in a function, it is not in. It does not run during the install or post install.
Mm-hmm. Okay.
Then will it still trigger? Because network calls
Yeah.
are. Uh,
That's where the static code like LLM help in. Like, if you have a network call, right? The YARA rule might match or the capability might match. So the LLM analysis might be triggered, and it can actually look up, is it does it fall under the context of the package? Does it fall under, if it's legitimate, if there's some unknown IP? So that's where the static analysis, LLM analysis helps it.
hmm, I hmm, I don't, because with an LLM you can very easily trick it by saying, uh, this is the config, or parse the config, or bury it into three different directions.
I mean, Karthik, no tool is going to be foolproof, but I mean,
Because static code analysis and dynamic code analysis, because when you see, there is a, with these kind of tools now, if you've seen Chrome in recent years and Firefox also, they have got, they have removed the green padlock for HTTPS. It is now, instead of marking insecure as a default and highlighting security, they are assuming security as a default and highlighting insecure connections. So because when if you have a package that is marked as safe here, then
Yeah.
people might not look very carefully at it, which counter, which ironically might result in it being more vulnerable. Such kind of,
Mhm.
so if some, because see, if you have a checkbox that says yes, this is secure vetted, vetted package, then we not, and that contains something like this, um, then it is even worse, no? Because then people,
Yeah. Uh,
only thing. Also, are you protecting overwriting of other packages or modification of other files?
so we like for these unknown cases, we specifically have like three terms. So instead of just malicious and safe, we have this term called suspicious, where if any of these YARA rule match, like you said, right, eval or network calls, we have this suspicious term where
What about
we
file
let the
system
user know.
access?
Sorry,
File system access.
uh, file system access. Sorry, can you?
Meaning, so some packages, they can modify other packages if there
Okay.
is. So, for example, there is a very popular cryptographic library for crypto.js in Node. Malicious package might override that crypto.js installation with their own installation. So
Mhm.
they are not modifying, they're not making network calls, they're not running malicious code, but they're overwriting a package that is used for hashing, for password comparisons, for cryptography with their own implementation.
But that is still some file system calls, right?
So that is what I asked. Are you tracking that?
Yeah, we are tracking all those file system calls, network calls, process calls.
No, but that will only trigger if you are install, if both packages are installed. Now, so that uh, you will not detect that by just running pre-install.
It would be flagged under the static analysis though,
How?
because it's a file system call, right? It's a
so in the
capability
code,
file system capability.
the code will be like, hey, copy XYZ from here to here or whatever. Like there'll be some code path in your code, right? Which is doing that. So he's saying in static analysis that might be caught, right? Even though I don't have the package when I'm testing it, I only have my own this current package and not the target package, but the current package might have something in its source code which is trying to do something like this, right? So he's
Yeah,
saying it
like
might be
the
there.
package is still importing some file system related libraries, right? It's still making some
Trigger on every file system library import, now, because that will then become too noisy.
Yeah.
Yeah, so we have some specific, you can say, capabilities that are marked as risky, such as network socket related, some specific syscalls, which I will have to look at, but there are some specific risky capabilities,
Hmm,
not like on all.
I see. And are you providing a registry as well for this, or
Registry in the sense, like for all those
yes,
packages.
for yes, for these packages?
So, like we don't really provide a platform to like look at all the packages, but you can use our tools to look at each package that you might be installing, or you might want to look at a single package. So you can scan for it, such as WIT lets you scan for each single package.
Correct, but is there a registry that will not allow me to install unvetted packages, for example?
Uh, I didn't understand,
You can
like
create
not.
a proxy, Karthik.
Sure.
You don't need a registry. You can create a proxy.
I think I can create a proxy, but are they providing something like this? क्यों मुझे
Uh,
करना?
You're providing two tools, right? So if you use PMG, Package Manager Guard, and you try to install a package that they think is malicious, they're going to block it.
That is kind of a proxy, right?
Huh? So they have tools, right?
Not
They gave you
exactly.
two
No,
tools
no.
to do
So,
that.
for example, I think there is an NPM registry that you can subscribe to that contains only vetted packages, and you replace the registry URL. So when you
Oh,
do
okay.
NPM install, it will pull from that registry install from NPM. Now, I think they
No.
are most likely mirroring NPM
Mhm.
or proxying it through NPM. But the point is, if you try to request a package that has not been vetted or a package that might be insecure, then the
Mhm.
production deploy will CI NPM CI will fail instead of first
Okay.
fetching the package, installing the package, and then realizing it is malicious.
No, we don't provide the registry itself, but the tools that we use, those don't actually like scan the or analyze the package at install time itself. Those actually just query the database. So
Right.
it's not like you have to wait for a whole package to be analyzed.
I see. Okay, good. Are your rule sets public or
Sorry?
are the rule sets public?
No, the analysis system is closed
I
source.
see. Okay, good.
Okay.
Does anyone else have any questions? Please feel free to ask Sahil. So, okay, I had one question when you talked
Yeah.
about using Google package analysis, right? Something like
Hmm.
that. You mentioned
Yeah.
that you were not using it because you were not able to find correlation between the two. So what are you doing there? Like you're not able to find correlation between static code analysis and
Yeah.
Google package stuff. So you implemented your own dynamic
So,
analysis.
so Google package analysis is also like similar to static analysis, where it has its own set of rules, you can say. So with dynamic analysis, we cannot really correlate with the result it provides, like the you can say the specific rule matches. So I have not looked at the Google package analysis deep, but the main issue we faced was not being able to correlate like the match or the results we have at our own static analysis level. We are not getting the same from the Google package analysis.
Okay, so currently how it works, so with your static analysis results and dynamic analysis results, what do you mean when you say you correlate them?
So
With your
like
current way, not Google Package Manager, with your current way. What
yeah,
do you mean when you say you correlate them?
so correlating it basically means like as you can see in this package, there are some arrows and there's a post install script, right? And based on those dynamic
Ah,
analysis results, which I showed you, like dropping and executing the
okay.
binary. So we actually correlate, like, does it really
Okay, so
matter? Like, what's the impact?
so if the static analysis says okay, post install is a problem, and then so in dynamic you check, hey, is the post install script actually suspicious, right? So you
Yeah,
check
something.
whether, okay, got it.
And dynamic analysis is not dependent on static analysis. Like it both execute for each package,
Hmm.
so
Yeah,
it's
yeah, yeah,
like
fair.
more secure.
Got it. Also, I was just curious when you talked about multi-layer sandbox, what does that mean?
So
How are you doing that?
so that's just didn't like Docker in Docker. So it provides
Oh,
uh,
okay.
like extra layer for Docker.
Hmm. Interesting. Okay. Yeah, fair enough. Just one random thing to share was so
Yeah.
talking about attacks, right? Social attacks, right? So sorry, security attacks or supply chain stuff and whatever. So something like this happened. This is more of a social engineering thing where someone during an interview, someone was the interviewer makes you install clone a GitHub repository,
Oh,
and
I got a LinkedIn message regarding this. They asked
yeah.
me to run a script on my system to
No,
uh,
this affected someone. This affected someone. So I got a call saying that, hey, I just had a friend give an interview, and this person installed, like, they were doing an interview, and during the interview, they made them npm like clone a repository, run npm install, and during that, they saw some weird random SSH stuff. Something came up, and then later on, when they checked the repository, they were copying all the SSH keys on the machine and sending it to some endpoint. And and they contacted me because I was at that time part of the campus expert program or whatever, right? So GitHub campus expert program. So they made me reach out internally and tell them to ban the repository and whatever. But that actually happened to someone that we know. So I was like, whoa, okay. And then they had to delete all their keys and remove it from wherever they were using it and stuff like that. So yeah,
Yeah.
crazy.
There was this like I have had similar experience like when I shared on Reddit, there was this one guy who shared like his friend got compromised in the same way, like during an interview itself. So it's like,
It's crazy.
yeah.
Crazy. Anyone else having any questions for Sahil?
So I had this question.
Yeah.
What does executing a package exactly mean in the context of checking for static
Execute.
and dynamic analysis?
Yeah. So executing basically means checking the install behavior of a package. So from the time the packages starts to install until the time the package gets installed completely. So like
So only the installation
and
code
behavior.
path, or also the utilities that the package provides you, like for whatever you want to do?
No, currently not the utilities because we don't have a way to actually execute or get the runtime running for those utilities because of the vast packages.
Hmm. Do you think this could potentially affect like the nature of the package, because you really don't know the runtime behavior of that particular package?
Definitely, like a static analysis at the end would just be able to, like mark or like trigger some specific rules, but dynamic analysis eventually gets you the main runtime behavior of the package. So if we are able to find some way to actually execute those utilities the package offers, it's going to be a very, very big like success path or actually marking the package as malicious or safe, much more clear.
Also, I wanted to understand, so dynamic analysis in this case, how
Mhm.
is it like, what tools do you end up using, and what level does the dynamic analysis, like what sort of response do you get from the dynamic analysis? Does it tell you that, hey, you have some dangling objects or something that is like created and not freed or something like that? What does dynamic analysis exactly internally mean? What does it tell you?
So from the output way, the only thing that we get from the dynamic analysis is events that the Falco captured, and those are the runtime events the package actually emitted. So let me just show you.
So you
Yes.
told me that you guys are using eBPF hooks. Did you build it, or
No,
are
no,
you
we are
you
using Falco, which internally uses eBPF.
okay?
So here's an Falco rule. So we have various other kinds of rules where we actually write those conditions or similar situations where if we find any specific, like Falco or Falco finds any matching condition, it would emit that event. So if I show you that event example, such as these. So
Hmm.
where in this case, the package actually tried to execute the binary. So this event was emitted and captured by the Falco. And on the right, you can see like what did actually try to execute Falco, like captured all the output.
So so dynamic analysis is done through some tool, and that is Falco.
Yeah, so dynamic analysis is, let me show you. Yeah, so dynamic analysis is basically just spawning a new dint container in an Kubernetes pod uh, and a Falco which monitors the system calls and collects all those events in an events database, like in the most simplest explanation. It's
Okay.
this much. Yeah. Uh,
Okay. I thought dynamic analysis meant something like running something like Valgrind or something which looks at the memory while your program is executing and looking at all the things that you've created and like forgot to free. That's what my understanding of dynamic
yeah.
analysis was.
Mhm.
But you're suggesting that you're doing something different. So, okay.
Yeah. So we are only looking at the events the package might be meeting, or the you can say the system calls it's making.
Yeah, that is relatively easier to trace. Yep. Okay.
I think
Yeah.
forgetting free objects is memory leaks, right?
Yes,
That,
those are
that
memory leaks.
yeah, so that can also be found by static analysis, right? I'm not saying always, but
Not always, but sure, you can.
yeah. Okay.
Yeah, like we're still trying to improve our dynamic analysis, like and get ways to make it more reliable. But yeah.
Do you know what Falco does internally?
Sorry.
Do you know, like, do you understand what Falco does internally? Like, how
Uh,
is it using eBPF?
no, I have a very like small idea about eBPF because when building the sandbox, I got to know about eBPF, but Falco,
Mhm.
how Falco uses it internally, I'm not aware of that.
Okay, cool. No problem.
Fair enough.
Oh, and
Anyone?
one
Yeah.
more. How do you deal with native bindings and things like BOSM,
Sorry, come again?
native binding, native packages,
Oh,
and WebAssembly?
uh, I actually don't have a quite answer for this, like reasonable answer for this, so I'm not sure.
Can you explain what you mean by how do you handle native binaries?
Because if it is compiled code, if it is a binary, then
Okay.
a shared library especially, then it's very, you cannot reverse it. You can decompile it, but that becomes a separate tool chain.
No. So binaries are not handled. So if you're talking about like native libraries such as binaries or compiled binaries, so we don't really like scan for this. We kind of consider them as embedded executables. Like if a package ships some executable, we consider them as embedded executables which are catched by our static analysis. We
And
don't
need
actually
basically
scan
itself.
them. Yeah.
So do you scan them or no?
No, we do not scan them. We just look
You
if it
just flag
ships.
them directly,
Yeah.
but not they don't care about what's in it. It's just malicious or suspicious.
Suspicious, yeah. It's like if there's like any event that was like suspicious during the dynamic analysis, we actually look at the results and monitor them.
Oh, for example, Prisma used to ship with a native connector for SQL in a shared library, .so library. So
Okay.
if you have something like that, then because see, most people will uh, if you, even if you flag it at your end, that is not enough because then there is no way to then move ahead. Now you either not you don't use the package or you accept the risk
Yeah.
and say, this is we have to use the package. So
Yeah.
so just flagging it, I don't think is a good solution. I say in the
Yeah.
WebAssembly, if because now Node.js supports WebAssembly and the browser also supports WebAssembly. So if you have a WebAssembly payload that is loaded into a lot of packages do this. They load WebAssembly formats or reasons. So if they do this, then there is if and you just flag that this package is using WebAssembly, then that is also not very meaningful because at the moment then either the team has to make a decision of not using the package or they have to say accept the risk.
Yeah. So again, like I would say like I'm not sure about those, but I would say like the embedded executables are like very you can say different. Like we don't really mark each like shared library or some binary that is being shipped as suspicious or there's like a different criteria for marking those as suspicious or like if it's really potentially threat worthy. So we do not mark each shared library or any binary being shipped, but there's still some criteria which I'm not clear about.
I see.
Okay.
And
enough.
last question, what about browser-only packages?
No, we don't scan browser-only packages. We have started with ID extensions too, but not browser packages.
Okay.
What are some examples of browser-only packages, Karthik?
React.
Okay.
Well, like those are npm package only, right?
Yeah, I mean,
No, but they rely on the DOM, they rely on the browser APIs. Huh? Do you polyfill those?
I mean, like if there's a package existing on any public registry that we scan, we can get the
That is
data.
static code analysis.
Yeah, static and dynamic analysis. We can get the.
yeah. Karthik, what do you mean? I think we just
I mean, like what you said, it would be hard for us to actually scan them.
There
Then
are a
we
few packages that
execute
rely on
those.
React. So no, so how do you execute them? Because when you import them, they need, for example, some of them need browser, some of them need window.fetch, they need
Yeah.
XML parser, or some of them need blob. Blob is there,
Yeah.
now, but
Yeah, it's the big issue. Like we don't really execute them because we don't have a way to execute all of those thousands of.
so you only do static analysis on them. Okay,
No, for dynamic analysis, we just do we check the installation behavior.
I see. Okay.
Yeah, because we don't have a way to have a way like a program that executes for each package. Like as React, you gave example, right? We don't have a way to set up the same browser and all of that.
well, at least for now. Who knows what
Yeah,
all we'll do in the future?
yeah, definitely.
Fair enough. I think with that we can. Does anyone have any more questions?
eBPF is really interesting. You guys should take a look at it.
Oh, okay. Fair enough. You can share your knowledge with us post this. But before then, thank you so much, Sahil. Appreciate you coming in and sharing your talk with us. Congratulations on giving this talk in Nalcon as well, by the way.
Thank you.
And another thing was to thank the entire team for working behind the scenes to get this talk up and plan everything and schedule everything, create messages and other things. So thank you. Um, Darshan, Pranav, Karthik, Ankush, Ayush, Alpesh. Appreciate y'all. Thank you so much. And yeah, see y'all next time for another talk. Thank you so much.
And thank you,
Thank
Harsh,
you.
as well.
Ankush.